So we could technically do this, but um, yeah, it doesn't look clean just yet. I mean, we could bring this a little closer. Maybe we could also try bringing it down one. I think one advantage we have with like these super open areas is that like you have a lot of freedom with the dash. Like you can go in almost any direction you want, but I still think we're trying like I don't think we found like the full potential for this mechanic just yet. That's just my opinion, but we're getting closer. Like while these other rooms have, I guess they're interesting, they're not like ideal because like you have to dash way too fast and they're like super cramped. I'll show you an example here. Like down here, for most of these rooms, like I like the idea, but it's just too much going on in a very small space. Whereas with this one, there's not that much going on, but it gives the it gives the player some breathing space. Also, we're getting our player to fudge into the wall, into this wall right here when we dash up, or when we dash to the left. So it's kind of ugly. So either we bring it down more and closer. I think if we, let me see. I think if we brought it to the left one, it'll be fine. What the hell is going on? We literally teleported over it. Oh, you know what it is? Our raycast, it detects anything when you're in the dash state. So if you are let me try that. I didn't even think to check that, like what we were colliding with. So, I mean, it doesn't seem to happen here. It only seems to happen in the force dash state. Trying to like replicate it, but it doesn't seem to happen. It's not happening. Let me see what state we're in. Whoa. Whew. I almost spilled my tea. So you go from the dash to the neutral. From zipline to neutral to dash. And press right, neutral. Let me see why we're not going into the bounce state. I think maybe we aren't resetting some variables for the player when they're in the bounce state. We'll see right now. Like force dash might not be set to false. I don't know. Let's see. State logic. Oh, let's check state logic. We are currently in states.dash. Teleport player. If not dashing and enter neutral state, we enter the neutral state. If enter force dash, we enter the neutral state. If we're in a spring, we should enter the bound state. So I guess we're never colliding with this spring. So let me look at. Let's actually check if we're fudging the player. That's what I assume is going on, but who knows? Yeah, fudging player, and it's happening. I never realized that we fudge player. Oh, I get it. Even though fudge player does run like a bunch of times, it only happens once. Like the function checks for a variable, and then it only runs once. Yeah, we're gonna want to make sure that fudging only happens when we're colliding with a tile map, and I think we already do something similar to that. Let me see. I know somewhere in our code we check if tile map. Yeah, right over here. Get collider.get tile type. So if the tile map is, or if our raycast detects a tile map, this is the only time that we should run it. So let's actually, if left wall raycast.get collider is in group, oh, if it's not in a one-way platform, okay, that doesn't matter too much. We just want to grab this one right here. And I guess we don't want it to happen in one-way platforms as well. Let me see. Platform. We're gonna have to fix a bunch of our code here. Actually, maybe it doesn't matter too much because it's always one-way platform is actually never going to be in our tile map, so it doesn't matter too much. Let's just grab this and in fudge player. So this is our stand. Oh wait, no, colliding, and then where do we actually check? Oh, okay. Left wall raycast, right wall raycast 1. We're going to want to say this. And I guess we'll probably want to do this first. And then this. Make sure these are the same. Hey, how's it going, Inut? What you been up to? Okay, so right wall raycast .get collider .get type. Only if it's a tile map do we ever want to fudge the player. That way, if you hit like a spike or something, you're gonna die. Or in our case, it was the spring. So I'm gonna grab this same exact function here. Just put it there. Push these over, and make sure this is left wall raycast. Okay, I think we have references to these instead of like grabbing it like this, but it's fine. Apparently, it's not that much slower. Like if you really wanted to optimize your code, you should grab a reference to this, but it's fine. If raycast.get what is this? Is colliding .get collider .get type on base null instance. Strange. Oh wait. Oh, we're grabbing left wall. So, oh, okay, yeah. So actually, we're gonna want to grab the is on wall. We want to grab what our what this is colliding with, not the raycast. Whoops. So I actually don't know how to do this, but I know we can find it in our kinematic body. Hey, how's it going, Shroom readers? Shroom let me see. I think it's in the kinematic body. Collider. It might actually be let's see. Get floor angle, get slide collision, get. Alright, let's look at collision shape. It might be there. Collision shape. 2D. One-way collision, get shape. Where is it? Alright, we'll just Google it. Godot. Get collider. Collision is equal to move and collide. Get slide collision, maybe? I think we use move and slide with snap. And it should run the same thing. So this should be in. This should be in our kinematic body, not in our collision shape. Let me see. Maybe I missed it. Get slide. Oh, right here. Returns a kinematic collision 2D, which contains information about the collision that occurred during the last call, move and slide, or move and slide with snap. Alright, let's try this. I assume it would be index 0 for I and get slide count. Oh, this could give us all of our collisions, but I guess it should only return. I assume it should only return one collider, because this happens immediately when we get one collider. I guess we might have an issue if we're like running this while we're simultaneously on the floor and hitting a wall, but we'll see. So instead of running this, for now, let's try just printing get slide collision on 0. Yeah, this is a kinematic body, so. Oh, okay, so get slide collision. Yeah, it won't run. I'm just thinking. Yeah, it won't run on a tile map. I mean, on a spring. So it says kinematic collision 2D. Let's see this again. Get slide collision, which contains information. Oh, dot collider dot name. That's what we need. So if we're getting the collider, we could just check for that type there. Wait, I actually don't know. I wonder if we are actually colliding with the tile map here. I don't think we are, though. Fudging player, auto tile 2. Yeah, we are colliding with auto tile 2. Let me see if this happens. Maybe it's just a matter of updating our raycast. But in this room, I'm just going to delete this for now and see if we still fudge the player there. Yeah, so that's what it's supposed to look like. I guess maybe we can try running this in like super slow-mo, invisible collision shapes. I'll try adding it again. Visible collision shapes should show us like the. I guess it should show us the hitbox. I don't think it shows raycasts though. Let's see. All right. Oh, and let's run this. Yeah, we'll try it. We'll try it really quick. Oh yeah, I guess we are hitting it. But what I am surprised about is that it's like super high. Like usually, I think something is wrong. Even if we did fudge the player, it shouldn't like teleport us up that high. I guess what's happening. Let me think about this. It technically is true because we are pushing. We're colliding with the player, and then our raycast doesn't hit anything, and our global position is already so high. So I guess we are being pushed up like 7 or 8 pixels. What we could do is grab that point of collision, and check. Basically, what we'll do when we fudge the player is instead of pushing their global position like plus 10 or minus 10, what we'll do is we'll check the collision point, and if that collision, like based on that collision point, we just want to push them basically up enough so that they don't collide with that body anymore. That's going to be a little harder to figure out. I don't know how to do it just yet, so we'll see. We'll see what we can do here. Let's see. I know there's like a get collision point with our kinematic body, so let's look that up. Godot get collision point kinematic body. Get collision point. If is colliding, collider is equal to get collider, and then we'll do collider. I guess we're getting slide collision, so this should give us everything, but if we get collider, then we can get, let me see. Let's try running get collision point. I mean, I think we might have to run get collider instead, but we'll try it here. If it doesn't work, we'll know. Okay, yeah. So we'll do. Let's comment this out for now. Strange. The method get collider. Oh. I don't know if this is like an old function because get collider doesn't exist. It seems like get slide collision should work, and we could get. Let me see. Let's search up. Wait. Kinematic body. Slide. Get slide collision, and then it returns a kinematic collision 2D, and then in our collision 2D, let's see if there's a dot position, dot get position. The point of okay, there we go. That's what we need. So, whoops, kinematic collision. Dot get position. So I guess what we would do is after we get this position, we would compare that to the player's global position, and if our player's global position is right here, we're mainly concerned with like this little section right here, not much what's above the player. Basically, we would check where this position is, or actually where this position is. And if that collision point is above it, we want to push the player, that many pixels, maybe 1 pixel above that collision point. That's what we're going to try to do, and it should be pretty possible. So that collision point is 7061, 7,000. Oh wait, no, negative 4,112. If we look at our world, I mean, it should make sense. But we're gonna compare the player's global position to that. Where was that? That was over here. Yeah, it's crazy. It's like right on the board. It's literally right there. So all we would have to do is compare our player's global position, or the bottom of the player, like the player's feet, basically. And the player's foot is what? Let me see. Why does it say this is 75? It's like it's 7.5, or I guess 8 pixels. Let's see what the what is the position of this raycast here? Left forward raycast is 8. Okay, so we're gonna grab the player's global position plus 8. Okay. So let me think about this. Global position dot y minus equals We're gonna grab this collision. Get slide collision 0 dot get position dot y. Minus our player's global position, or maybe our player's global position minus this position, which would give us. If our player is like right here, that's 4120. Let me just grab a calculator. Negative 4120 minus, or I guess plus 412. Oops. That's negative 8. That would push our player 8 pixels up, but we want to grab the distance to that. I'm trying to think, how would we do this? Basically, all we want to do is push our player up 2 pixels, but it really depends on where we collide. So like if the player collides right here, we want to make sure that we push them like 4 pixels up. If they collide right here at the corner, we just want to push them up 2 pixels at max. I'm not a math major, so I'm trying to figure out what we would do for this. Minus equals. We'll just mess around with these values. Player. Let's just do global position. Someone said math. Yep. I said I'm terrible at math. Global position minus. Oh, global position dot y minus this. And yeah, this gives us negative 8, but we don't need negative 8. But I guess technically we do need negative 8. Okay, and then we'll do plus, or wait. So if it's negative 8, we want to do plus, I guess plus 9. I think that's what value we would want to give it, or maybe plus 10, because this would give us an extra 2 pixels. We should like record this value plus 10, because we might change the player size one day. But for now, let's actually see if this works. Oops, put it right here. So wait. Yeah, player's global position would be plus. We would have to test this out with all cases. Player global position minus equals global position is equal to 0. So what I'm doing here is I'm subtracting the player's global position. Well, no. We're subtracting our player's global position by the collision point, and the collision point should be like less than the global position. So right now, if we look like in our current scenario, our global position was like, let's say it was global position is 8 pixels higher than this collision point. So we get negative 8 here. And then when we do get negative 8, we just add plus 10 to get, we'll be 10 pixels higher. The negative 8, which is 2 pixels, but we're minusing it, so it would be 2 pixels higher. Yeah, exactly. Well, let's just see if it works. Yeah, there we go. So it works for this case scenario. I don't know if it's going to work for other things. I mean, we could try it here. We literally just need to fudge in corners here. So I can remove the minus equals and the global position. Are you sure about? Oh, so you're saying I can just literally, instead of doing global position, I can just do get collision point plus 2? I think you're right. Oh, this is actually minus 2 now. I just want it to be 2 pixels above the collision point. Oh, wait. Can it be? Get slide position would give us something. Yeah, we set it to equal up. So equals collision point. So like if our collision... Wait, I still think we might need the global position. Because we need to compare it. Like, it's not always going to be a static value. Like, it'll work for this case scenario, but it's not going to work for everything. Unless there's something I'm missing. Like I said, I'm not like crazy at math, but my logic right now is telling me, hey, I need the global position. Yeah, negative is up. I can't just set it to negative 10. Okay, let me start over. I'll try to explain what I'm doing. We are fudging the player. Basically, what fudging is when the player dashes into a corner, we want basically there's like a margin of error where we could push them up if they hit a corner. So, for example, pretend my mouse is the player, and pretend it has a way bigger. You know what? Let me just use the player. I'll move around the player to show what I mean. All right, the player's dashing. Let me close this window. Our player dashes into this corner here. As they hit this corner, if they're still in the dash state, we grab this collision point. So the collision point is going to be like right here. Actually, I don't know where our collision point is, but this is just 1 pixel. So it doesn't matter too much. I think that actually that's something that we need to consider. What is our collision point? Because over here it said that it might grab the highest collision, like the upmost or the lowest collision point. Let me see. I won't look it up just yet. But yeah, for now let's work on under the assumption that our collision point is the highest point right here, but sometimes it might be down here. That's why we need to grab the collision point and then compare that to the player. Well, this was my original thought, is that we need to compare it to the player's global position so that we can move them only just 1 pixel above this whole thing, 1 pixel above the collision point. Corner, I think. So yeah, that was my initial thought. Let me see. Let me just see if it works this way. We're gonna try the. So maybe you can see what I mean when I did this. Global position dot y minus equals. We're grabbing the collision point and then we're adding 10 to it because we just want it to be 10 pixels above the collision point. Or the reason why it's 10, it's technically only 2 pixels above, but it's because the player center position is like it's right over here, but we're actually only comparing it to the player's feet. That's why I put plus 10 originally, because plus 10 is like is down here. You could have some raycast point down at the side. Yeah, so that's what I did. I do have raycasts. I could run this with raycasts. Right now I'm using the player's. So we're using a combination of raycasts and the player's collision point. So like basically, if this raycast up here, if this raycast doesn't hit anything, that's our indicator to say, hey, let's fudge the player. I could bring this down a little bit. I thought I'd recycle this raycast, like similar. We have this working perfectly on the like the ceiling raycast. We fudge the player on the ceiling, but for the side raycast, because we have 2, it might be a little weird. I might want to put another one in the center. That global position is doing nothing. Try writing it without minus equals. Or 1 raycast per pixel pointing forward when sprinting. Yeah, writing it so it does the same thing. I'm just trying to think how we could set it. Like if I did write equals, how would I know where the player is? Like we're trying to compare it to the player's global position. Global position. If I were to write it without the globe, if I were to write it as global position.y is equal to something, here, I'll try it. Global position is equal to, let's see, we need our collision point, which is whatever this is. Here, I guess we could try it like this. -2. But yeah, the thing is, it's not always going to be -2. There's always going to be, we're always going to fudge the player in a different position. Like, you see what I mean? Like sometimes it might be -2, sometimes it might be -10, or sometimes it might be, well, actually not -10. I think the range is going to be between like -2 and maybe, I think up to 8. So it'd be between -2 and -8, or -7. If I did just if you're saying just substitute equals global, so if I literally wrote this, this would push our player into -2 or whatever. You know what I mean? I mean, actually, this would literally just be 2. Our global like if I just wrote this, our global position .y would be on 2. At the global position .y. Yeah, I'm having difficulty understanding. Here, try writing the whole thing, like what you think the thing should be. It's kind of hard to say, like, or read, like, global position minus equals after equals, like, it's, I don't know. Can I paste the line in chat? Yeah, I got you. Hey, how's it going, Mildown? Is the same as global position .y equals global position .y minus global position .y. So then what's the difference? Why should I write that instead of what I wrote? On the second line, you can see that global position .y cancels out. That's why it wasn't. Wait, no. The thing is, I want it to cancel out. Oh man, I feel like maybe there's some. I don't know if I don't know if I'm stupid or if there's a miscommunication here. Here, you know, I still haven't. Why use the minus equals? Here, wait. I'm just gonna test it out and we'll see if it works. Maybe I'm just missing something. We still want to grab. We're basically what I'm doing here is I'm just grabbing the distance between the player's global position and the collision point, and then adding 10. That's all I'm doing. And then yeah, subtracting that this value, whatever this gives us, I'm adding 10 to it, and then I'm subtracting our player's global position from that. That's all I'm doing. Wait, here, let me just run it and see. And we'll test this out actually in a better room, or I'll test it out here, but we'll just add some. What's going on here? Oh, I think we ran the wrong room. I appreciate the help, Crazy Stewie. All right, so okay, so my method towards it is not working. And I don't think the collision point is enough for this. I could have 1 pixel per. I could have a raycast per per pixel. I wonder if that's like, is that too much? I feel like that's like, it's overkill, but it would give us the most amount of what is it like responsiveness. Like we would be able to handle every single case. Just force update. Yeah, I might do that. We might just do that. So maybe for now we'll leave it. Maybe I won't update it for now. So this was my original. What I did originally was literally just set global position minus equals 10. And that basically just pushed our player's position up enough. But the thing is, if we hit a corner, we do have 2 raycasts here, so I could check if this raycast is hitting something, and if it is, I can even do raycasts in code. Look this up. Godot. So yeah, we could run multiple recasts. I'm just wondering if that's like, if that's a good way to go about it. I see. There's no way to find out where the ledge is. Okay. So yeah, maybe we'll do that. I don't know if I should do that during this stream, and it would definitely make things easier because we would just like iterate through each of our raycasts. So maybe for now, let's see. Okay, so yeah, the main issue right now was that when we are trying to, let's see, line 1906, there's a check mark. What does that mean? Oh, that was accidentally placed there. You meant the thing on the left side? Hey, how's it going, Montmartre? Is that how you say it? One raycast, point down on each side. So yeah, actually, that's what I did with our floor raycasts. And see, there's like these little raycasts right there, but I actually don't use this as often anymore. It wouldn't be a bad idea to put one on each pixel. And I mean, it's not like we have a crazy amount. Like, it's not like I think our max size is like 24 by 16 or 16 by 24. So it's like we could do that. Hey, how's it going, Ichachi? We're just doing some level design / trying to figure out what's the best way to like handle collisions or handle fudging for our player, which is like I guess figuring out like the margin of error that we want to give our players. Hey, how's it going, Sparky? So yeah, maybe we will try doing it the raycast way, and I'll do that today actually. Since I think it'd be pretty fun for the stream. Let me just back everything up. And we'll try it out. Yeah, you know what's funny? Like, there have been so many times that I rewrite the same like mechanic over and over again. I mean, I guess that's part of like, you know, reiterating through your game and like making it perfect. But like, you know, I've already rewritten like the jump mechanic so many times. I've already rewritten the dash mechanic so many times. The bounce mechanic. Almost every mechanic in the game has been rewritten like a crazy amount of times. And now we're rewriting the fudging mechanic, which is something that's relatively new. But I guess that's expected if it's a new mechanic that I haven't fully explored. With the raycast pointing down on each side, you can get the exact position of the edge, and with multiple pointing horizontally, you have a 1 pixel resolution. Yeah, I definitely agree. I don't think I need, at least right now, I don't have any mechanics that really need for you to like, I don't need raycasts on the bottom just yet, and I don't think I need raycast. Like, I think for the top and the bottom, we could just have this one giant raycast down the middle, because like that's how I handle the fudging for like if you're dashing upwards. Here, I'll show an example of that really quick. So this is what fudging typically looks like in our game. Let me get rid of our hitboxes, because it does make our game lag a bit. Calculating the offset is easier with one raycast pointing down on each side. Actually, you might be right. You might be right about that. Maybe we don't need, like, maybe max we need 3 raycasts on each side of the player. So like 3 on the left, 3 on the bottom, 3 on the top. I'm trying to think. But yeah, like, see how the fudging works here? It basically just checks like if our player is colliding with something and the raycast in the middle doesn't hit anything, we just push the play. We just move the player up a specific amount of pixels. Usually it's just yeah, right now it's a set amount. So in our player fudging function right here, let's see. Yeah, we just move them 7 pixels to the right or 7 pixels to the left. Ideally, what I wanted to figure out was how to move them, you know, maybe not always move them 7 pixels, but maybe we just want to move them 5 pixels or 4 pixels or maybe even 2 pixels. So if we had a bunch of raycasts, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess 10. You can do that without any extra raycasts. So how would you do it? But yeah, also having 3 raycasts wouldn't be a bad idea either. If we just had 3, when we saw this raycast hitting something, we would grab that position, and then we would. Let me think. How would it work? I mean, we know our tile map is always in sections of 8, so it wouldn't be too hard. But we also have to consider the player's size. Like, it's kind of like it's not a symmetrical size, you know, like right here from the bottom, like our player, I guess you could call it like I don't know, the center of gravity. I don't know, like our origin node is much closer to the top of the player than the bottom of the player. If the top isn't colliding and the bottom are, move the player up 2 pixels. Oh, so keep fudging the player until the raycast doesn't hit anything? Is that what you're saying? That's also, actually, yeah, that's also a really good idea. Yeah, I actually like that more. That way it's not crazy with the raycasts. Yeah, every time it runs, it like pushes the player up 2 pixels or 1 pixel. Okay. So I guess we would make it like, I don't know, would we have to write it like recursively then? Like we would have to keep fudging the player until one of these raycasts or loop. Okay. Yeah, while the top is colliding and the bottom isn't. When you say top, like right now I'm thinking of the left side. I'm not too concerned with the top just yet, because like the top, like dashing upwards is not really an issue. Oh, okay, that's weak. Okay, yeah. I mean, we could always update the top, but right now, like gameplay isn't really affected too much by the dashing upwards fudging. It's mainly only affected by the dashing horizontally gameplay. So yeah, the only thing is that currently I use these raycasts to check if we should enter the slide state. So I'm just wondering if we should move this up a bit. If we do, like if I move these to the edges here, then I might as well have 4 raycasts, because maybe we'll have 3 in total. One at the top here, one at the bottom here, and then one in the center. I think the center one would be most important for entering the slide state. Alright, we already backed everything up, so we might as well try it out. Maybe I should organize these raycasts a bit. Alright, let's move this up here. We'll just try it. Yeah. And then there is one other edge case that I think I might want to include, and that's like if the middle raycast is colliding with something, then we don't want to fudge the player at all, because that's already the halfway point. So I guess we would compare. I think instead of comparing it to the top, we would compare it to the middle. Alright, so let's make another raycast here. We'll put it down here. Where's right? I guess we could duplicate this one. It's not a big deal. So yeah, this is called 3, and the left wall recast is 3. Okay. Maybe I wonder if I should bring this closer to the maybe towards the player's neck rather than the origin. That way it's a little more consistent here. Yeah, like something like that. Or yeah, this is the exact center, so we'll do that. Is there any case where you have a gap that you can't fit through? So sometimes we might have usually I avoid this. Like technically we could have something like this where you have to dash through here. We are going to handle fudging like going like this, or pretend pretend my mouse is the player. Sometimes you might dash and fudge this way. Sometimes you might dash and fudge this way. Usually, I like to give the player like as much area as possible. So I think most of our gaps are 4 pixels or 4 tiles high. I don't think I ever make it a case where it's like 2 tiles. Like the player could technically fit through here, but it's too much of it's too demanding from the player to like dash that well. So yeah, it's usually going to be 4 pixels, maybe 3. Or 4 tiles, I mean. Also, it's really weird for me to see the origin in the middle like that. I always keep it at the bottom for characters. Yeah, I guess you're right. I've been developing this game for 2 years, and I started working on this game when I was still learning Godot. This was originally supposed to be like a 2-week game that I was working on. And so yeah, like I've learned way more since then, but yeah, like there's still some things from, the old, when I was first learning that have been like built into the game. After I released the Kickstarter, I plan on like refactoring everything and maybe spending maybe a month or 2 just almost redoing everything. And just like optimizing everything, because yeah, like right now, it's a lot to like redo everything right now, but I do want to do it eventually. So yeah, I guess we could try it like this. Let me see if the wall slide. I wonder if we should enter for the wall slide. Maybe we'll just have it check the middle raycasts. Let me see how this looks. Am I gonna try iterative fudging now? Yeah. We're definitely going. We're gonna try the method that you mentioned. I just want to see what it looks like now that we have 3 raycasts. And the original raycasts are on the border now rather than like in the player. I just want to see what it'll look like. Something like this. Let's do that. Okay, yeah, so the only issue right now, I guess what we'll do is we'll have our middle raycast check for most of these. Let me think. And so yeah, obviously something like this we don't want to happen. Like, you should not be climbing. And this is because the raycast is so high up. That's going to be an easy fix, right? And then as for the fudging still works because our raycast is way up there. A 2x2? You want to see a 2x2? We have a 2x2 over there. mean, but yeah, it's the same thing. Oh, the auto tile bit mask? Yeah, this is a 2x2. Alright. Let's get to it. Okay, so if fudged, I guess we would have to get rid of this, because like lately what I did was I had it so that fudge, once you fudge once, you won't fudge more than once. But I guess now we are going to fudge more than once, or fudge until we can't fudge anymore. We're gonna fudge so hard. So let's see how we can go about this. Yeah, fudge. Oh yeah, fudge once, but like iterate through it, right? Yeah. Okay. So we have this if is on ceiling, and then is on wall. So I guess we're not going to check is on wall. We're going to check if left raycast one. So let me just see these numbers. Maybe we should rename this to like floor raycast, floor left raycast, floor ceiling or floor top left raycast, something like that. Let's just make those a little bit more organized. And do we have anything for our raycast? No. Okay. Let's just do this. This is our top. Our top is raycast 1. So let's do, oops. Our middle one is raycast 3, and then this one is 2. Yeah, I could drag them from the tree, but I'd rather just write it. Raycast 3, this is left. Oh, whoops. Okay. Maybe we could put this here just so it's organized. Alright. So if is on wall, so we're gonna handle is on wall. If left wall raycast 1, we can do. So we're gonna be checking for our left raycast. So let's do if left raycast, if bottom left raycast node is colliding equals false and dash direction is wait, we do right. Oh yeah, so it's right wall. right bottom raycast node is colliding is equal to false and dash direction is greater than 0. Then we're gonna have to check if the middle raycast is colliding, right? If actually no, we'll first check if the middle one is colliding. So if right oh wait, no, this should be middle. If right middle raycast node is not colliding and our dash direction is vector 2.right, we'll basically keep fudging our player by 1 pixel until the right bottom raycast node is not colliding. Yeah, we'll do while in a second. I think we would do while fudged is equal to false. I'm just wondering. Would we have to create another variable saying like we have to fudge? Because right now what I do is I'm always running fudge player in our while in state, I'm pretty sure. Yeah, we're always running fudge player. The is colliding if becomes a while. Okay, let me see. Is collide. Oh, holy cow! You code a lot. I guess I think it's relative. I feel like I don't code enough. But yeah, I guess to someone who, if you don't code that much or like you don't do it too often, it probably does seem like a lot. So you're saying while is colliding is equal to false. Oh wait, no, that's right here. Well, it's always going to be equal to false. But you're saying, oh, what? Oh, here, right. While bottom right cast is colliding, then this, and I guess then we'll set fudge equal to true. Oh, actually, no, we'll do it at the end of this while. And then we'll do the same thing here. You force update raycast. Okay. I didn't know that was a thing. Thanks for all the help, Stewie. Hey, how's it going, A98K? Set fudged inside the while. Oh, right. Yeah, you're right. So this is only for the if we're fudging upwards. We still have to do it for the bottom, but it basically almost be the same exact thing. Yeah, you only fudged if you actually moved. Okay. So yeah, let's run this. Let's see if this works. I don't know if we don't necessarily have to run is on wall anymore, but it won't hurt. Yeah, it seems like it works. Let's see if okay. So yeah, we are hitting it here. Maybe I have to move it down 1 pixel. It seems like our hitbox is hitting it, but our raycast isn't. Set visible collision shapes. Does is on wall use middle? Is on wall is no, it doesn't. It uses the bottom and left. I mean the bottom and top. Wait, no, is on. Let me see something. Yeah, is on wall uses our collision shape. That's the kinematic body function. So wait, yeah, it would be returning true. I mean, we could check. Make sure they aren't 1 frame behind or something. Oh yeah, no. The middle one is only. I'm pretty sure it's only checking for. It's not checking for areas. Let's see. Yeah, it's only colliding with bodies. So it shouldn't be colliding with anything. Yeah, so yeah, we are running is on wall. It's right there. So that's printing true. But I guess I don't know. I guess our raycast is not hitting it. Do we have to run force update maybe earlier? When am I going to publish this game? So you can actually play the game already for free. It's just an outdated version. Here, I'll send it to you. It's on itch. If you have Windows, by the way. Here's a link. Try for updating for raycast before the ifs. So let's do this. Well, yeah, let's just see if it works. We'll update the left bottom and the right bottom, and if it works, then we'll update all of them. Dash direction is wrong. Oh yeah, you're right. This is left. So maybe we didn't have to force the update. There we go. Very nice. Thank you, Stewie. All right, so now we have to do this with everything. So, I guess we could also just write the other while here. And thanks for the follow. Oh, I'm glad you like it, Scout. Oh yeah, yeah. Press download now. Don't worry about like donating or anything like that. It's fun. It might. I've gotten some complaints that the game is too hard. I'm hoping this next version should be a lot easier. Yeah, careful with. Yeah, I was thinking about that too. Yeah, I think it should be fine. Biggest problem? Oh yeah, like if we're trying to. Oh yeah, let's actually check that. Let's see, like into like a one tile, into like a one tile gap or something. I don't think that's ever in the game, but who knows? I mean, it's not like it's impossible. Oh yeah, like it shouldn't be more than like 8 pixels, so we could just add that. Left top, top, right top, right top. Wait, it's actually. Get rid of these visible collision shapes. They like make my game lag a bit. I'll see you around, Scout. Thanks for trying it out, and yeah, I'll see you around. Oh yeah, look at that. If we dash into, like, I guess if we dash into a gap, we go all the way up until, cause it like loops through. Like, I mean, I guess what we could do is just inside the while statement check if we're colliding with anything and make sure that we stop the fudge. So I'm pretty sure if we did something like this, we're gonna go all the way up here. If I can catch it. Yeah. I'm actually surprised it didn't go like all the way up. I'm trying to think. Why didn't it go all the way up? Yeah, if the middle one starts colliding, we would end the fudge. But I'm wondering why we didn't go all the way up here. I mean, I guess it doesn't matter. I mean, it's a bug to begin with. I'm. 'Cause, 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 mean, we could just say end this. Yeah, that would. Yeah, we could limit it. I think we could also just make sure that it does like handle all cases where it doesn't happen. But yeah, it could be a check. Like, I don't know, maybe there's like an edge case that we haven't thought of. Oh, this should be left. Wait. No. Should be. Any tips for level design? So yeah, level design is actually my least favorite thing to do. There are moments when I really like to do it. If I get like into the habit of it. I could check the. Oh yeah, you're right. Oh, oops. I guess we'll just put it here. When fudging up, stop when top collides. Is that what we did? Oh, the second. Oh. All right, I think that's it, right? Yeah, we'll add the limit to our fudges. Well, yeah, it's not gonna happen. It's kind of hard. I think it's going to be much harder to ever fudge downwards. I think it's going to be less common. Wait. Wait, we're I think something's not right here. So is it because maybe our while statement here, this one's running first, left bottom raycast node, if it is colliding and, no, wait, if top is colliding and this one is not colliding. Yeah, oh, yeah. Is this the bottom one? Let's try it. Maybe I didn't save. There we go. So yeah, it shouldn't. I'm wondering. Maybe we should move. Yeah, I think the raycast is like directly in the middle, so it is fair, you know. Looks a bit up to me. Let me try this again. You think it should be lower? Let's see. I mean, yeah, I guess because the player's arms are like all the way down here. This hits -5. Oh, actually, -5 and whatever this is. It doesn't say. Oh, it's this is 8. Should be at -3. Right? Or 3, I mean. Oops, nope. Should be like that? No. There's a ruler tool. How's the ruler tool work? Oh, whoa! I didn't know that was a thing. So this is 7. This is 6. So it's not an exact pixel. I could put it. I could put it in the middle here. Is that a weird thing to do? Let's see. Was that 2.5? Oh wait, is it 1.5? Yeah, I might even mess around with these with the player's hitbox and everything. I kind of want to make them a little wider, just because it would make the game more. I don't know. I think it'd make the like. I love the way the player looks right now, but at the same time, it might be better to make it more, make our player more square, instead of like, they're kind of narrow right now. But yeah, it does look pretty good. Or like, yeah, it works. We still have to fix some of the animations. Oh yeah, we have to fix the slides now, since our raycasts are way up there. So yeah, we could clean up a bunch of this. This is what actually puts us in the. All right, I'll see you around, Crazy Stewie. Thanks a lot for all the help, man. Really appreciate it. All right. What should we do now? I think we'll work on the slide states later. And the climb, because I mean it just works. We just have to move around the raycast or like optimize it a bit. Let's see, maybe, I think when we first started this stream, I was trying to do some level design, so I guess we'll get back into that. Let's get rid of all of this and see how this looks. That doesn't look too bad. What I'm thinking, though, is maybe we can make this a little more exciting. So right now you just dash up. Maybe they have to dash left. Maybe we could bring this up higher. They have to keep dashing left until, I don't know, maybe they reach it up here instead. Let's remove this one here. Let's bring this up a bit. And it'll be more like a race. So have another one going up here. 7 pixels up. So 1, 2, 3, 4, 5. Actually, no, wait. This is our bounce, which I'm not sure. I think it brings us up maybe like right here. We'll find out in just a second. But it could be 7 tiles across. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Yeah, I can bring it like right there. Oh, whoa. Yeah, we could do that if we wanted to. We can make them dash a little bit more if we wanted to. It is kind of hard to catch. Let's try doing some more of this. One, two. I'm wondering if we should move our curve, like each of our curve points. Every time we set it up, they're always bound to like, these little sections right here. I think. Let me see. And we could move it around. Right now, they're bound to these little sections here. Let's see. Smart snapping, or this. Yeah, you can never put it like in between points. I guess not sure why. I think if we were to set this to 4x4, it'd be easier. Or what we could do is set up a system where every time we put it on one of these points, we would just move all these points to the center. If we do that, we just need to make sure that it's always like on the left side of things or on the right side of things. It's hard to figure that out. Well, it's not hard, but it might mess us up sometimes. Here. That's not bad. This is sort of the mechanic that I was going for. Or like type of gameplay that I'm going for. And now we just need to make like a bunch of stuff like this. Let's see how we can do it. This is 4 tiles here, and this is also 4 tiles. Okay. Yo, how's it going, Chev? So one thing that's slightly weird is that the center of our spring is not centered with this object here. Like we would have to push this over here. I mean, it still works. Like we'll still hit the hitbox, but maybe we'll want to push this to the right one. Oh, but then this will mess up. I mean, it'll still work though. So, currently we're just doing some level design. Someone was on the stream earlier and they helped me a bunch with the fudging, and it looks a lot better now. Or it's just a lot more, makes a lot more sense, and it's It's a lot more responsive. Stevie guy, yeah. Crazy Steve. He's so crazy. Alright, so this is the first part. I'm wondering, you wish someone personally trains you. You could find, I don't know, like usually with that kind of like, there are a lot of courses on there, but I know some people work better when someone like trains them or like teaches them, like, you know, like a personal trainer, obviously. Like, I guess that's the first example that I could think of. But you could, there's so many YouTube videos out there, so if you have, you know, the discipline, it's most definitely possible to learn Godot. Let's see. So we're at this point. I guess we could do another 4 dash to the right this time, and then figure out how to make the player race against this 4 dash. What is this? Not 90, 0? Okay, yeah, 0 degrees. Put it, do we have like a specific value? I don't think we do. I was thinking of adding another mechanic where like you could dash in and it'll give you like a wait time, like a timer, that you could stay inside that box before the orb picks you up again. It's like a train, you know, you're waiting for the train to pick you up. But it also might not be necessary. We need to add more spikes around here too. Like spikes right here. Let's see what we could do. What kind of game am I making? I'm making a platformer. If you've heard of Celeste, it's very close in gameplay to Celeste. So we're 4 dashed out. Maybe we could do something where like the player has to wall jump all the way back up. I think we tried this before, but it didn't work out as planned. But who knows? Maybe it'll work this time. Yeah, the issue with this is that we don't want to make the gameplay too clunky. And right now we're only using 1 zipline, so if you die, you have to like start all over. So we want to make sure that there's a lot of places to die in case they don't make it. Because if they don't make it, then they have to drop all the way back down, and that could mess them up. So we'll have to figure out what to do there. Or what we could do is make it so that there's more than 1 orb attached. So like we were saying with the box here, maybe. Yeah, maybe if you die, you can continue on to this to the orb. Like the orb will spawn near, but that's something that I would have to like code in, and I think that'll take a long time. So for now, let's just see what we could do with what we've got. To do something like we dash out, dash, jump, jump, jump. Oh. Let's try this. Oh, we can't catch it. I think, yeah, we'll have to push that force dash up a little bit. Oh, that's also something that's interesting. That our global position, I guess because I'm pressing. Yeah, we're so slow. Dashing upwards is so slow. I mean, doing wall jumps is really slow. Like, we won't be able to catch up to this orb here. Unless, like, you dashed up, caught a spring right here, jump, dash. I don't well, let's see. So we kind of get close. I think if we put more springs around, we could maybe make it. Let me see, dash here. Maybe we'll make this a little wider, something like that. We could even include like a force dash somewhere. Maybe force them to dash sideways here, and then after they dash sideways, they can dash up. Let's see. Have to lower it a bit. Let's see. This, I think, will go to the left one. Bring this here. This will have to go down maybe 2 tiles. This will go down 2 tiles. Let's have maybe. Well, actually, we don't actually have to make this lower. Or add more, we could just bring this down a bit. Something like that instead. Maybe we can get rid of this altogether. One thing that slightly bugs me is that like we're not able to, we like have to, we have to like time our dashes. is also kind of hard. Especially since we don't know how other people are going to play. So it is possible to catch. It was pretty hard to do that. Did my stream freeze? I don't think it froze. Okay, it's not frozen, but it might have been. Okay. Pro parkour. Yeah. It does look good when the developer can play it well. But I don't know how it's going to look when other people play. We can get rid of this. We could actually just leave this as a box here. We're going to be putting spikes everywhere. And as for the timing here, I don't know. I don't know what we could do. Because we're a little too fast. See how we're too late, or we're too fast to catch it. So I mean, what we could do is maybe add some delay. Maybe add another obstacle for the player. Yeah, that's kind of a big issue. Because everyone's going to be playing differently, and we don't want to, like, I guess, force the player to wait for something. You know, if like someone's really good, they'll get way ahead of the curve, and then, yeah. It wasn't your internet. Okay. Yeah, I don't. Usually when something happens on OBS, it tells me like, hey, your internet's not working, but I didn't get anything. So maybe it was like a restream thing, like maybe their servers were a little messed up. I don't know. I'll be right back. I have to use the bathroom. Hey, how's it going? 4,423,467. How you doing, man? I'm doing pretty good. We fixed a slight bug with the help of someone who was watching the stream earlier. So that was pretty cool. I think they helped like optimize like the responsiveness of the code. Whoa. I've never seen that before. We like bugged out for a split second. But yeah, this is pretty good. Right now I'm struggling to figure out how we're going to get our timings to work properly with the speed of our zipline. Like it might make sense to just remove the zipline altogether, or maybe add it for like another mechanic, or like just another part of the game. Because right now I don't know. Yeah, we might just remove the zipline from the demo. Like I do like the mechanic. It's just, how are we gonna get this to work? I don't know. How long have I been working on this project? For 2 years now. So yeah, like it's most definitely, you're able to catch it. But if you're too fast, you're ahead of the curve. So like, basically there's like it's forcing the player to work around the game rather than having the player go at their own pace. And I don't usually like that kind of style. Either you're too fast or you're too slow. And I feel like that could be frustrating for people. Oh, thanks, man. I hope so. You never know, though. I mean, I think we always want our stuff to work out, but I feel like it's more luck than anything else. You know, there's so many games out there that are really good, but it's not about how good your game is. It's if the algorithm gods tell you your game is good. Yeah, we are trying our best here. Of course, yeah. So, I mean, you can play it now, but if you go on, I think I posted a link. Yeah, if you look at if you look at the description on itch, there should be a link to my itch page, and that's where you can play it. But it's an older version. This version now, which I think is a lot better than the previous versions. Yeah. Wait, I already lost where I was going. Yeah, this version is a lot better, but yeah, the core mechanics, I guess, are still there. They're just a lot cleaner now and more responsive. But if you like the base game or the original base game, you'll probably like this version as well. I think we have to fix something with our input. If I press dash simultaneously when we exit like a spring here, it kind of like messes us up. Let me see. When do I think of releasing it? So I plan on releasing the Kickstarter and like the full demo in December. I'm hoping for December, but I don't know yet. Yeah, ideally for December, but who knows? And then for the actual game, I'm hoping 6 months after the Kickstarter, I'll release the full game. So, if everything goes according to plan, it should be June. Should be released in June. You wish you didn't have school. Yeah. Yeah, it's hard to multitask. I definitely could not. Oh, look at that. Another bug. Oh, you know what it is? It's because our top raycast is colliding with the ceiling right now. So yeah, we'll fix that. That was a part of the plan, but I'm probably going to stop streaming pretty soon. I might stream again later tonight. I need some time to think about what we're going to do with this. Oh, I think I figured out the bug. Let me see. Yeah, okay. So what happens when we enter the bounce is that there's an input dash delay. So what's happening here? I press B, and the second I press B, there's a like. If you don't have your dash right away, and then you press what am I trying to say? You dash, you press the B button, you don't have a dash, but then the second you hit the spring, your dash gets reset. We need to make sure that dash input is set back to false the second you hit this. But we also need to make sure that if you have the dash prior to hitting this, that you could still dash out. So that there's like some edge cases that we'll have to fix for that. Let me write that down, and maybe we'll work on that in the next stream, and we'll work on figuring out what we want to do finally with the ziplines. Well, thanks. I mean, it's not. I don't think it's a matter of being smart. It's just, I've worked on this project for so long. I know what needs to be done, what doesn't need to be done. I don't know. Like, someone who's smart is just someone who's done something for a very long time. Like, how do you become a really good programmer? You just program. It's not like most people aren't geniuses when they get into programming. They've just done it for a long time. And I've done it for almost 8 years. Honestly, I don't think, like, for someone who's programmed for 8 years, I don't think I'm that good, but I'm probably good compared to someone who hasn't programmed that much. You barely get time to watch a tutor. I mean, make my game. That's funny. Watch a tutorial? I mean, yeah, that's how you start it. My first game here. I'll actually share with you how I made my first game. So I watched a YouTube video by this guy named Mizzies. Here, I'll show him. Give me 1 second. So yeah, there's this YouTuber called Mrs. He's a Godot tutorial, and I remember the only reason I found him was because I was trying to make a roguelike. So if we do roguelike, yeah, he made this game right here. And he open sourced it. And basically what I did to get into Godot is I watched this video, and then I made my own version of a game, which was this, Mind Against Misery. So I'll just download it because wait. Oh, you've only programmed for a month? You got a long ways to go. 4 million. But yeah, I mean, after you've only programmed, you use Unity. I mean, yeah, it doesn't really matter what engine you're using as long as you stick to one, So yeah, this was the game Mind Against Misery, and you might see, like, in his video, I didn't really showcase the video, but it's very basic. Basically, I think how it works is you have 2 moves for every 1 move that your enemies get, and then he showed you how to, like, procedurally generate stuff, or procedurally generate rooms. I think I used his method for generating, like, room types, but how I found another video that showed me how to make rooms similar to Binding of Isaac, like how to generate rooms similar to Binding of Isaac. And I think I made a YouTube video from it. Might have, but it was also from another tutorial that I watched. So yeah, you kind of just learn from other people, and then you put your own little twist on it. So I think I downloaded the game already. We have to copy this. Let's put this in downloads. Let's just put this. Let's make a new window. go in here. This game might be very loud. I apologize. I don't remember having any. Oh, we could fix it though. So let me just. Yeah, this is the game. Let me see if we can. Volume mixer. I hope you guys don't hear, even though I lowered it on the volume mixer. I wonder if OBS still picks it up. Let's see. No, it doesn't. Okay. Yeah, exactly. I have a similar attitude towards it. I kind of just okay, yeah. So yeah, this is the game, and it's very similar to the one that guy made. But what I did was I have these little pickaxes, and you have 10 pickaxes, and you have to find a key. Basically, all you do is you collect pickaxes, and the pickaxes allow you to break through these walls. You can collect keys, and then you go through here. You can't break these walls, but you can go through this door if you found the key. And then you exit. This is what the game usually looks like. So you look for every move that you do. I think for every 2 moves that you do. Oh, I already died. But yeah, those guys follow you around. But there's also a time on them. So every 0.5 seconds they follow you. So as long as you're moving around, and you can't. You have to like dodge them, kind of. You can't kill them. You go around looking for the key. But yeah, this was the game. This was my first game. I don't know why I decided to share it. I think we might be trapped here. Yep. That's it. I am going to head out now. So I will see you guys later. If there were more people, I feel like OBS is bugged right now. It says 7 people are watching, but on YouTube it says 1, and on Twitch it says also 1. I'm convinced it's a bug. In 2014 was when I started making games, or playing games. Yeah, I think I started playing in like 2007 or 2006. Not mentioning all the web programming. I've been programming. Oh, I see. Chev said that he was programming since 2014 and 15. Yeah, I think I started around the same time, but I was a sophomore in high school. Oh damn, you were born in 2007. Wow. I was like 9. I was 9 in 2007. We're turning 9. Ugh. Yeah, I think OBS is definitely bugged because Chev and A98 are definitely here, but it's saying only 1 person. But yeah, I'm delaying me leaving the stream. If you guys want to keep talking, I can talk for a little bit, but programming and game dev is over. Let's do this. Stream is ending. Do this. But I'll leave my face. It's my face. All right, fellas. I think I'm gonna head out. I will see you. Till next time.